Solutions for mini test 1 for vectors and kinematics. So question 1 over here, we've got a parallelogram. So first thing I would do is, I'm given a parallelogram, I'm given 2 points. 5, 6 is the first point. -2 and 7 is the second point for A and B respectively. So I would at least, to start off with, I would just try and sketch it out first. So you've got the O being the origin. And we also got 5 to the right, 6 up. So something in the first quadrant, about a point over here would be point A. We've also got 2 to the left, so not a lot to the left, but more downwards. So it's more like that point there. So quite down we'll have the point B. So we can kind of like picture that the parallelogram is going to be something like this. If I want to like sketch a parallelogram, which means that your point A will be here. Now, immediately, what we kind of see is, I'm just going to label this as 5 and 6. I then label the point as -2 and 7 first. So we know it's a parallelogram, which means the opposite sides must be parallel and equal in distance as well. And also the fourth point, which is point C. Now, whenever the question says like OACB, it would be like the points are in this position as well, like O then A, so it won't be like O then C. Now, just reading that, the question wants us to find out the coordinate of point C. So a couple of common mistake when I was like marking your mini test. The first thing is we write coordinates as a horizontal row. So we write horizontal like that, but we write vectors vertically as a column, which means that in order to go from O to C, which is the coordinate of C or the position vector of C, you can either go from like O to B, then B to C, or you can go from O to A, then A to C. So I'm probably go for that method. So I'm probably go for O to A and then A to C, because I can see that that's going to be the same as O to C as a triangular vector, but I already know what A to C is. A to C is going to be the same as O to B, because it's a parallelogram, which I'm worded as -2 and 7. I also already know what O to A is. O to A is 5 and 6. -2 and -7, sorry. Which means that in terms of a vector, O to C as a vector will then be O to A plus A to C, which is 5 and 6, and then added by -2 and -7. So that becomes just trying to add numbers together, which is 5 minus 2, which is 3, and then 6 minus 7, which is -1. So O to C must then be, as a vector, we can kind of see that that's about that coordinate as well, which is 3 to the right, -1 to the 3 to the right, -1 left, -1 downwards. So that's the first part A. Part B of the question tells us about midpoint. So the common mistake over here is, first of all, where is the point M? The point M is somewhere in the middle where the diagonals meet. So it's going to be, it says the midpoint of A to B as a vector, which means that what is A to B? So GCSE tells us that in order to go from A to B, we've got A to O and O to B. What is A to O? A to O must be -5 and -6, and O to B is -2 and -7. I think my coordinate here is wrong. Need to do -7. Hang on, let me put it here. -2 and -7, which means that here, when we have got A to B itself, is -7 to the left and then -13 downwards. So it must mean that in order to go from O to M, because M is the midpoint of AB, so O to M will be somewhere here, where's M. So we'll go from O to A first, and then we'll do half the journey of A to B, which is half of AB. because half of AB is, we know, A to M. So O to A must be 5 and 6, and A to M must just be half of -7 and -13. So that must means that we're doing 5 and then taking away, just putting this here. Okay, so meaning that we're doing 5 take away a half of 7, which gonna give us 1.5. And we're also doing 6 adding it by or taking away a half of 13, which is going to give us -0.5. So we've got O to M as a vector. Now, how can we go from M to C? So M to C, we can either like quote, it says prove that OM to M to C, but that's a parallelogram property that we can use. Is half of O to C. So you can use that. Alternatively, if I want to go from M to C, I can go from M to O and then O to C. That will work as well. So what is M to O? It's going to be -1.5 and then 0.5. Adding it by O to C, which is what we found out earlier in part A. So that's part B, and then label part A as well. So here we've got O to C, which is 3 and -1. So we can just do 3 take away 1.5. 3 take away 1.5, which is just 1.5 as well. Together with a half -1, which is also -1/2. Which gave us our nice proof of having both of the vectors O to M and M to C, and we can see that they are the same. O to M is the same as M to C as required. Lastly is the part C here, which is finding out the distance of M to C, which is a 1.5 squared plus -0.5 all squared. It's the size of the vector. So the size of the vector is just the square root of the Pythagoras. So 1.5 squared plus a half squared, giving us root 10 over 2. Root 10 over 2. And that's it. That's this question 1 over here, which is a vector question. Question 2, we've got a kinematics questions with graphical methods. So first thing is I can see that we've got two particles, two vehicles. One is a car and the other is a motorcycle. So they started off both at rest at time t equals to 0. And respectively, the car follows a journey. It accelerates and then constant speed. The motorcycle also follow another journey. So it described that it accelerates uniformly for 9 seconds until it reaches 36 meters per second. Alright, so it seems like the first stage is like a triangle. For the motorcycle, it accelerates for 9 seconds, so that's the base of the triangle. The height of the triangle is 36, which means the gradient is 36 over 9, or you can call it the acceleration is 36 over 9. So 36 divided by 9 is nice number, it's 4. ms minus 2. And then so it will go up and then flat. Now another thing that I know is that just by reading the question, I've also got a car itself. So it told us that it's a 6, so it's a sharper line and then flat. It told us about the height, which is 30, and the acceleration, which is 30 divided by x, right? This space is x. It's going to be 6. So x must be 5 by inspection. So we're just trying to like merge these two together, because the first one is a car and the second one is a motorcycle. So just by inspection, acceleration of the motorcycle we already know is a equals to 4 ms minus 2. The drawing on the same speed time graph, we just need to like merge the two graphs that we have got together now. Couple of things. We have speed, we have time. 6 is a sharper gradient, and then it will reach a lower line, which is 30. So if I call this 30 and I call this 36, it must mean that it's sharp and then horizontal, whereas the other one is a flat one, then horizontal. And in terms of the base, the time, we already know that this is 5 and that is 9 as a time. So that's the speed time graph. The other thing is we may want to like illustrate it in terms of like some labeling. So the one with the red in color, I can label that as car, and the one with the blue in color, I can label that as a motorcycle. So that's the part B of the question. Drawing on the same speed time graph, the movement of both vehicles. The question then tells us the value of t for which they draw level. So the keyword about draw level is when the distance they traveled is the same, which must mean that in terms of like the distance traveled, up to a point here, which I'm going to call it t, then that time is the value of t for which they are level. So what this allows me to do is to focus on the two different trapeziums. The first trapezium is the trapezium for the motorcycle. For this motorcycle, we can see that the top of the trapezium, because the whole length is t, and this length is 9, so the remaining length at the top must be t minus 9, and the base of the trapezium must be t, with a height of 36. For the other trapeziums, which is a sharper one, I can see that the base is also t, but the top is t minus 5, with a height of 30. So we're just trying to equate them. Trapezium's areas are the same, which is distance t. So t minus 9 plus t over 2 times by 36. Because when they overtake, they must have traveled the same distance. So one is faster first, and then one catch up with it when the speed is 36, and then eventually they catch up together. So those two distances must be the same. So t minus 9 plus t over 2 equals to t plus 5 plus t over 2. The whole thing times by 30. And then cancel out the 2. You've got 36 bracket 2t minus 9 equals to 30 bracket 2t minus 5. Which means that we can easily expand and simplify. I'm going to do the long way. 36 times 2 is 72t minus 36 times 9, which is 324. It's going to be the same as 60t minus 150. So bringing it all to one side is 12t equals to 324 minus 150, which is 174. So t as a time, we divide it by 12, which is going to give us 14.5 seconds. And that's it. That's your part C of the question, for which this is your question 2 here. Find the value of t for which they are leveled.